Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. The next of the 5 fundamentals of RF you must know, the third, is RF measurements. So we need to know how we look at an RF signal, measure it, and understand how strong it is. Now we can measure RF signals in absolute and relative units. We'll talk about absolute first. Milliwatt is a common measurement. A milliwatt is 1/1000th of a watt. So if we say we have a 1000 milliwatt signal, then that means we have a 1 watt signal, okay? Usually we're looking at milliwatts in indoor wireless LANs at a range somewhere between 5 and 50 milliwatts of output power. So these are the actual power levels in milliwatts. Now, the issue is that we don't use really very high output power levels, but we do use very low output power levels, or at least very low received power levels. And because of that, it's good to have another absolute measurement, and that is what we call dBm, decibels to milliwatts. Now, a decibel itself is a relative measurement. A dB, that's a relative measurement, but dBm is an absolute measurement because it's a decibel relative to milliwatt. That is, 0 dBm equals 1 milliwatt. So when we talk about negative dBm values, we're not talking about something like we have negative power. We have less than some power. No, we're not saying we have less than some power. We're saying we have a certain amount less than 1 milliwatt. We always have something positive. So our power received at the antenna is always positive, but it's somewhere between 0 and 1 milliwatt. Well, that range can go to many, many decibel places. So rather than saying 0.00000000037 milliwatts, we would instead use a dBm value. So for example, notice that when we look at negative 40 dBm, we're talking about 100 nanowatts. So obviously, we don't want to have to do all of the decimal places to get to that point. So you'll see these dBm values in tools. When you look at RF signal strength, it'll tell you the power level in dBm in many cases. And the reason it's doing that is to avoid having to put some field of .00000, and who knows who would understand it anyway. So it makes it more human friendly when we're dealing with power levels.